Hi, buddy. This is Mr. Folly, and welcome to a group of longer podcasts. Those 5-day podcasts are pretty much over. 5-minute podcasts. The 5-day ones are coming. So, explain why bonds form in terms of valence electrons. Kind of did that before. Describe what happens to valence electrons in covalent. We're talking about covalent or sharing electrons for this podcast. Say what types of elements are most likely to be found in each type of bond. Again, focusing on covalent. Use electronegativity difference to identify bonds as ionic, polar covalent, or non-polar covalent, which you hopefully picked up one of those in class. Describe the distinguish between properties of ionic compounds, blah, 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 blah. Name and write the formulae of molecular compounds. Let's hop to it. And let's stop share. All right, covalent bonds. Oh, share. Covalent bonds are between two nonmetals usually. Every once in a while there's a metal and a nonmetal, but typically it's not. They are directional covalent bonds. So for example, if I have carbon to oxygen, they share right here, bam. They do not do like metals do and have electrons that are shared all over the place. They share specifically with two atoms. It fills the octet through sharing. Okay, so why do we do it? To fill the octet because you get full stability and lower energy. And it double counts like your house. So for example, if I'm looking at a NH3 bond. Nitrogen has 5 electrons, right? And it wants to have 8. Hydrogen has 1 electron. If I aim these guys like this. Now, in a bond, they share. Oh, share. Oh, share. Oh, share. So nitrogen has 2, 4, 6, 8. And isn't that nice? So nitrogen has 8, and nitrogen equals 8, which equals happiness. Hydrogen has 2. Now you'd think, but doesn't hydrogen want 8? No, no, no. Remember, hydrogen's way up here on the top of the row with helium? It only needs 2, so it's full too. So if you asked hydrogen how many electrons it has, it would say 2. If you asked nitrogen how many electrons it has, it would say 8. Okay? So I say it shares, it double counts like your house. So if I asked you, do you have a house? You would say yes. And if I asked, Haley, do you have a house? Yes. Does your annoying little brother have a house? Yes. Does your annoying little sister have a house? Yes. Do your parents that love them more than you have a house? Yes. So, well, maybe they don't love them more than you, but you get the idea. But all of them would say yes, and it's still just one house. Okay? So it is one house, but you would all say yes. So it counts for all of you. Ionic to covalent is a continuum. Okay? Continuum means that there's ranges that go through it. If there's no difference in electronegativity, it's nonpolar, and you've seen this before. Some difference, it's polar, 0.5 to 1.9. And lots of difference is ionic. So a continuum would be like, look, it's ugly. Hey, look, there's your King of Hearts date. Average looking guy, Tom Hanks, the average looking man in the world, and you could be beautimous. Oh, yeah. So beautimous right there. Or you could have a continuum of brains. People in Hinsdale, that's smart. 4th hour, not exactly bad. And then 6th hour with their beautimous brains. So there's a continuum to go through those things. So it's not like there is a huge jump in between them. You just have to draw a line somewhere. Again, this is a repeat. We've seen this exact slide. 0.4 is nonpolar, 0.5 2.0 is polar, 2.0 and above is ionic. What's N to O? Notice, subtract those two. 0.5, it's polar. F to F, so it's 4 minus 4, 0. Nonpolar is the difference. Lead to fluoride, again, lead 1.8 to 4.0, that's 2.2. That's ionic. What is C to H? H isn't listed, but it is 2.1. So 2.1 to 2.5, the difference is 0.4. That's nonpolar, which again is rare to have a nonpolar bond where the things are different. Nonpolar covalent bonds. Two nonmetals. Nonpolar covalent bonds means that they share perfectly evenly. Look at the little rats are sharing so evenly. Oh, isn't it cute? So are shared evenly. The electronegativity difference is 0 to 0.4. For a homonuclear molecule, one that contains only one kind of atom, the bond is always nonpolar covalent. So those would be diatomics. C to H is 0.4 nonpolar, and that's such an important one. You need to have that written down and remembered. They have the lowest boiling points and melting points, and it never conducts electricity because there's no ions, and it's a poor heat conductor. Polar covalent bonds, two nonmetals mostly. A polar covalent bond has uneven sharing. See this? They're sharing a strawberry, and yet, no, that's not happening. This is the norm. Most of the time when you share, you cannot share with other people perfectly evenly. The atom with the higher electronegativity will still have a slight negative charge. the other atom will have a slight positive charge. So for example, if I shared a dog with Drew, and we have a dog, wags his tail. This is me, this is Drew. We share a dog. We both buy the food, whatever it is. What happens is the dog likes me better. He would run to me, but I forgot to draw legs on him. So he goes to me better. Now, if I'm not around, because Drew killed me because he wants a friend from the dog will roll over to Drew. So we share it, but it's never really shared evenly. Okay? A molecule with an uneven distribution of charge is said to have a dipole. Di means two, pole means end. That is called delta. The delta symbol represents a partial charge on each side of the molecule, as indicated. The arrow symbol points towards the negative side of the molecule, and this indicates the positive sign. And polar things dissolve in water. For the N to O bond, if we looked at the electronegativity tables again, whoops, you have the sheet, I hope. N to O, O is more electronegative than N. So that means if I were to draw the arrow, I would point at the bad one. Okay? And the symbol would be delta negative, delta positive. Kind of looks like a musical note, but only kind of. What type of bond is made of two metals? Now this is reviewing the bonding we did before. Two metals, metallic bond. My choices are metallic, ionic, and polar covalent, and nonpolar covalent. And these are both types of covalent, but we'll see what we can do. Conducts as a solid, only metallic. Has a low melting point, both covalents, polar covalent and nonpolar covalent. Has electronegativity difference of 2.2, that's the biggest difference, that's ionic. Has an electronegativity difference of 0.2, that would be nonpolar covalent, so it's very small, right? Less than 0.4. Transfers electrons, that's ionic, I remember that. Shares evenly, share evenly. Nonpolar covalent. Polar means ended, so there's no end. Has the highest boiling point, ionic. Is soluble in water and a high electronegativity difference. So, soluble in water and a high electronegativity difference. This is a bad question written by me. It's either ionic or polar covalent, because polar covalent has a pretty big electronegativity difference, and it would be soluble in water. So, soluble in water and a low electronegativity difference. Oh, well, I guess this would be polar covalent only. That's what I get for making up questions off the top of my head. Naming molecular compounds. Now, these are wonderful to name. I think one accidentally slipped in on one of my tests once. Two nonmetals. You use prefixes. Mono is 1, di is 2, tri is 3. Tetra is a little bit different. Tetra, if you've ever played Tetris, all of the Tetris pieces have 4 blocks. There's 4 blocks. 1, 2, 3, 4. That's how Tetris got its name. 1, 2, 3. There's the L. Then there's a little... I wish I could remember the Tetris theme song. We just saw it in the band thing. Penta is 5. Hexa is 6. Hepta is 7. It's not septa. It's 7. Octa is 8. Nona is 9. That's probably new. And deca is 10. So we're going to end in "ide" and sound good. Only the second atom ends in "ide" and sounds good. Okay? So let CO be your guide. There's no mono. CO is carbon monoxide. I'm assuming you know that. Carbon monoxide. No mono on the first one. It's not monocarbon monoxide. No double O's. It's not carbon monoxide, although I wish it was, because that would be so much fun to say carbon monoxide. Another word I wish I could say, like hurricane. So, and no double O's. I just did that one. So SF6. S is sulfur. S-U-L-F-U-R. Now, I didn't put a mono on it. Prefix for 6 is hexafluoride. PCl5, phosphorus. Prefix for 5 is pentachloride. Xe2Br8, xenon. Oops, not xenon. Di-xenon. Di-xenon. Octabromide. And typically noble gases don't react, but because xenon is so far down on the periodic table, it is able to lose its electrons a little bit. This is water. Or something else, but we're not going to do that. Trinitrogen monosulfide. Trinitrogen, N3, prefix goes with that. Monosulfide, S. Hexasulfur, 6 sulfurs. Dichloride, Cl2. Decanitrogen, N10. Monoxide, O. Sodium dihydrogen phosphate, that's a metal. So I do my charges. Dihydrogen phosphate is H2PO4 negative. So it is NaH2PO4. Be careful. I tricked you. I tricked you. Do not reduce molecules. Molecules are exact formulas. Reducing changes the identity. Your DNA is really chossed with some numbers. So maybe like C300, H950, O71, S43. But if you reduce that, of course, that's not reducible. If you reduce it, it will cause a mutation because it would think that it would be simpler. And you won't be able to do chemistry anymore. Or think. Or breathe. Or go on Snowball that most of you are doing right now. Review. Oh my goodness, I can't believe we're at the review because it didn't take as long as I thought. There are 3 types of bonding. This was a review. This is new. This is a review. So no, covalent bonding is 2 nonmetals. Valence electrons, share. Hey, we're listening to share. It never conducts electricity. Has a low melting point and boiling point. Only polar covalent is soluble. And it is the lowest strength of bonds. To which I will say, you should believe in life after love and toodles. Who doesn't like share?